Hi guys, Mr. Sonnenberg here. Today we're going to be talking about chemical bonds. So this is for you Science 9 students studying matter and chemical change. This is going to be topic 6 in your textbook for study reference. First thing we're going to talk about is basically what are compounds. So we've talked about compounds as pure substances. And so what they are is a combination of two or more types of elements, and they're going to chemically combine in a set ratio. So basically we take two or more elements and they combine together, and they're going to form two types of bonds. They're going to form this ionic bond, and then they're also going to form this molecular bond. So a couple examples of compounds. Well, we can just say H2O. Okay, that's one. CO2. Those are compounds taking two or more elements forming together. Or another one's going to be NaCl. That's your table salt. Carbon dioxide, water, table salt. So what are ionic compounds? Well, ionic compounds are a combination of a metal and a non-metal. So we know on the periodic table where metals and non-metals are. So that's what this is going to be, a combination of a metal and a non-metal. Molecular compounds going to be a combination of two non-metals. So they're going to form together. So we have non-metal and a non-metal. Sorry, I'm a little distracted. My dogs are screaming by me and barking. I apologize if that's on the screencast, but I gotta look after the little fur balls. So, alright, so that's what molecular compounds are. So an ion compound is a combination of a metal and a non-metal. So I'll just draw this again. So ionic is metal and non-metal. We have our metals here in purple or pink, however you want, and our non-metals and noble gases, but our non-metals are going to be in, oh, there's the dogs again. Non-metals are going to be in green. So non-metals are on this side, okay, non-metals, I just ran out of room so I did that, and metals are going to be over here. So ionic compounds are going to take one of the metals and they're going to form with a non-metal. That's ionic. Okay, whereas molecular is going to take a non-metal and a non-metal. They're going to form together and they're going to make a molecular compound. Molecular compound. Okay, so using the periodic table, this is how you can help yourself understand these compounds. So molecular compounds, what are they? Okay, well, molecular compounds, like I said, so an example of that, they're a combination of two nonmetals. So an example is H2O. Another example is CO2, it's carbon dioxide gas, and we can say water. I need some water right now, I'm quite thirsty, so I probably already said that. But what's happening here is they're forming using what we call a covalent bond. It's a weak bond, but they're sharing electrons. This oxygen and hydrogen, they're sharing electrons and forming that bond. So what this is going to look like, we see these numbers here, like we see these subscript numbers. So this is called subscript. We've talked about them a little bit, not extensively, but subscript numbers. And what do they mean? Well, that basically means for every one atom of oxygen, there's going to be two atoms of one of oxygen, there's going to be two atoms of hydrogen that combine to it. So if I was to draw this out and just say my oxygen is in green, so I'll just put a little O inside for you guys, and then let's say in blue I have hydrogen molecules or hydrogen atoms. Okay, well, these are hydrogens, the blue. For every one oxygen, there's two hydrogens. Now this is a little confusing at times for people because they say, well, there's no subscript on the oxygen. Well, just when there's a subscript of 1, we write nothing. Same thing as if there's a coefficient of 1 right now, we don't write anything. So you can assume that that 1 is right there as well. So for every one oxygen, there's two hydrogens. Okay. Now on the other side of this equation, we're going to see carbon dioxide. So that means for every one carbon, there's two oxygens. So if I draw my carbon atom here, then I should have two oxygens that go along with it. So if I have one here, these are my oxygens. Where did I get those two oxygens from? Well, I got it from the subscript number right here. If I was to add one more number here, and let's do a 2. If I was to add a 2 in front, that's called a coefficient, that number. So coefficient, that's coefficient. If I add that, that means what I have to do is I have to draw another one of these, because that means there's 2 carbon dioxide molecules. So then I'd have to draw that, and remember, for every 1 carbon there's also 2 oxygens. Okay, so looks kind of like a little face there, but these are the oxygens here. Those are the oxygen, and then the carbon is in the blue. That's the carbon. Okay, so that's how we form molecular compounds. Now we're going to talk about ionic compounds. So what are ionic compounds? Are the combination of one or a metal and a non-metal. Okay, and they form using ionic bonds, very strong bonds. Oops, not bonds. Bonds. Okay, ionic bonds, they're strong. Strong bonds form a crystal lattice, and they're chemically combined. So what our example was NaCl. Well, here Na is our metal, and Cl is going to be our non-metal. So these metal and non-metal, they combine and they form an ionic compound. So this ionic compound, here's an example of it forming right here. NaCl, metal, non-metal, we could find them on the periodic table, and they form ionic bonds, very strong bonds. Okay. The last thing we're going to discuss is polyatomic ions. Now, polyatomic ions are, oh, I forgot ions up here, sorry. I'll just talk briefly about them. But charged particles, they have 2 or more atoms, and they're held together by covalent bonds, and they're going to be on the periodic table. I'll also give you guys, or provide you guys, with a list of these polyatomic ions. But I'd like you to understand it. I'd like you to know them, so you can quick reference them when you're looking and naming, and also understanding formulas and naming compounds and such. So I'm just show you 2 examples. One is nitrate. Okay, and its symbol is going to be NO3, and the other is going to be nitrite. And these are naturally forming. Nitrite. I'm going to get rid of that A and just draw an I in here. Sorry, my bad. NO2. Okay, I always do. They look like Z's. Okay, NO2. So nitrate and nitrite. These are polyatomic ions, and they're going to be very important when we're naming compounds and when we're also writing formulas. So that is chemical compounds. There's going to be 4 more screencasts. Please stay tuned. Watch them all. And remember to play, pause, rewind. And remember, please, if you have any questions, bring them to me at the next class. I want you to bring questions to me. I want you to write questions down. I don't want you to be scared to ask questions. Here to help you guys. These screencasts are here to give us more time in the class so that I can answer your great questions. I hope this has helped, and we'll see you guys on the next screencast. Thanks for tuning in, guys.